This is part 3 for Unit 8, which is stoichiometry, and it's about limiting reagents and percent yield. Okay, so this is the final part that your homework is about as well. Okay, so balanced chemical equations are again like a chemist's recipe, and there's always something that's going to determine how much product you can form. It's actually going to get used up completely, and it's going to be called your limiting reagent or your limiting reactant. You should know that definition. Really, it just determines the amount of product that can be formed. And then there's something called an excess reagent or an excess reactant. So remember, these are always going to be the things you start with. And there's always going to be more than enough of those. Okay? They're actually going to be some left over when you get done. A way to kind of think about it is if you have a loaf of bread and you have a giant, jar of peanut butter and you have a giant jar of jelly. And you were supposed to make peanut butter and jelly sandwiches. Well, every sandwich has to have 2 pieces of bread and some peanut butter and jelly on it, right? So the limiting reagent for that would be whatever you're going to run out of first. Well, the first thing that you would run out of in that scenario would be the bread. So the bread is going to be your limiting reagent or your limiting reactant, because once you're out of bread, you can't make any more sandwiches. But you are going to have peanut butter and jelly left over, so they would be your excess reactants. Okay, I have an example here about s'mores, and if we have 10 chocolate squares and 20 graham crackers and 8 marshmallows, and every s'more requires 1 chocolate square and 2 graham crackers and 1 marshmallow, what's the limiting reagent? Well, you have to think about what are you going to run out of first. Okay, you have enough chocolate squares to make 10, and you have enough graham crackers to make 10, but you only have 8 marshmallows. So once you use those 8 marshmallows, then you're done. So the marshmallows become the limiting reagent, and the excess reagents would be your chocolate squares and your graham crackers. Now these are live examples of this, but in chemistry we get to use, chemical reactions to do the same thing. Okay, so here's another live example. I have a burger here, and I'm given all of this stuff. Well, in every burger, I have to have a bun, 2 pieces of lettuce, a piece of cheese, and a burger. So I have to say, how many burgers can I make here? Well, I have a bun, a piece of cheese, lettuce, and a burger. I have a bun, a piece of cheese, lettuce, and a burger. I have a bun, a piece of cheese, lettuce, and a burger. Well, now I'm out of lettuce. So I can only make 3 burgers. And what's the limiting reagent? What did I run out of? Well, I ran out of lettuce. So lettuce is the limiting reagent. Whereas the buns and the cheese and the burgers I still have excess of. Those would be excess reagents. Okay? All right, so suppose we have 3.8 moles of hydrogen, and it reacts with 2.2 moles of oxygen. I want to figure out what the limiting reagent is. So I have this reaction, because hydrogen and oxygen make water. Okay, it's balanced, and I'm given 3.8 moles of hydrogen. So, and I'm given 2.2 moles of oxygen. I want to find out how many moles of water do each of these make. So I'm going to go ahead and start with my 3.8 moles of hydrogen. And for now I'm already in moles, so doing my stoichiometry, I'm going to create a mole-to-mole ratio. I'm going to do that using the coefficients of the balanced reaction. So on the bottom I'm putting 2 moles of H2. And on the top I want to look about my product. How much is made, okay, with this? So I'm going to be able to I'm going to have 2 moles of water. Okay, remember the 2 comes from the coefficients. So then I multiply and divide, and that means I can make 3.8 moles of water. Well, I need to also look at the oxygen. How much water does the oxygen that I have make? So I'm going to do that one too. So I'm going to do 2.2 moles of oxygen, and then for every 1 mole of oxygen, I get 2 moles of water, according to the balanced chemical reaction. Okay, or equation, multiply across the top, and I can get 4.4 moles of water with that amount of oxygen. So once you get that, you say, which one has the least amount of product? Well, if you look at it, 3.8 is less than 4.4. So this is the least amount of product. Since this is the least amount of product, that means that my H2 is my limiting reactant because it's the lower amount of water. So that would make H2 the limiting reactant. You'll have to do this on your test and tell me which is the limiting reactant. Okay, I don't want to do this example actually because you're not going to have to do excess reagents ever. So I'm going to skip this example and we're going to click through it. Okay. Now, how many moles of water are produced though? I could actually ask you that. So originally, since hydrogen was our limiting reagent, okay, then we have to start with the 3.8 moles. And we said that in part A, when we did 3.8 moles, that it made 3.8 moles of water. Okay, everybody remember that from part A that we just did? Okay, now I want to see how many grams that is. Well, that's really just a mole conversion, because I know in every 1 mole of water, there's 18 grams, because that's the GFM. So I can do that mole conversion, and I can go ahead and say that there's 68 grams of water formed. Okay, so that's one way to look at it. You can do it like that. We could have also just originally solved for grams of water, and we would have had our answer and our limiting reagent at the same time. And I'll show you an example like that. Okay. So here's one. How many grams of hydrogen can be produced when 4 grams of hydrochloric acid and 3 grams of magnesium are put together or used as reactants? So we start off with the reaction of Mg plus 2 HCl yields MgCl2 plus H2. We're given 3 grams of magnesium and 4 grams of HCl. But I want to know how much hydrogen's made. So I can go ahead and just solve that for magnesium first. So I have to change grams of magnesium from grams to moles. Divide by your GFM. We're following our mole map again. So that's 24.3 grams for 1 mole. Then make your mole ratio. Use your coefficients. 1 mole of magnesium for 1 mole of H2. Then convert from moles back into grams. So multiply by your GFM of the H2, which would just be 2. That will end up with 0.247 grams of H2. Well, we were also given 4 grams of HCl. So let's see what that makes as far as our hydrogen. So if we have 4 grams of HCl, we have to change from grams to moles, divide by the GFM. Then we have to do our mole to mole ratio. So for every 2 moles of HCl, we have 1 mole of H2. And then change from moles back to GFM or back to grams by multiplying by the GFM. So when we do the math on that and multiplying across the top and dividing across the bottom, we get 0.110 grams of hydrogen. What's the lower amount? The lower amount is the 0.110 grams of H2. So that's the amount that can be made, and HCl is going to be our limiting reactant. That's the kind of question I would ask you on the test. And I would say, how many grams of hydrogen are made, and what's the limiting reactant? This is exactly what you'll be expected to do on the test. Okay? So, I don't really want to, assuming STP, what is this volume? So we knew that we could get 1.10 grams of it. So we know for every 2 grams, so change it from grams to moles. And then we know for every 1 mole, there's 22.4 liters. That's actually a mole conversion. So just realize that that's not anything new. That's just taking an answer that you had gotten and converting it from one units to another using moles. Okay? All right. Now we also have one other topic that gets covered in this, and that's percent yield. Theoretical yield is the amount that should actually be formed. If you do that calculation on paper, how much would get made? It's always the maximum amount of product that could be formed from a given amount of reactants. All right? Whereas, I was trying to erase that, not make more. An actual yield is the amount of product that really forms when you do the lab. It's considered your experimental value. It's always, it's often, I say, and I don't know why it says often less, it's always going to be less than your theoretical yield if there's not any significant errors in your lab, okay? You can't ever get more out of a lab than you're expecting to get. So that's kind of one of those things. Theoretical yield is your expected, actual is what really happens, or your experimental. Okay, now we have a formula for it. Your percent yield really is just a ratio of actual yield to theoretical yield. So you take your actual and you divide it by your theoretical. Actual is typically, like I said, going to be measured in the lab, or it's going to be given to you in the question. Theoretical, you're going to have to calculate doing stoichiometry. Then you'll multiply it by 100%, or 100, so you can make it a percent. Okay? Oh, and I have some different numbers on this one. That's why those numbers are there. So we'll erase them though. That's okay. All right. So I'm asking for what the percent yield is if I have 3.74 grams of copper, and it's going to, so copper is a product, okay, and I'm going to start with 1.87 grams of aluminum. So I'm going to find out how much 1.87 grams of aluminum actually makes of copper first, okay? So I'm going to say, I'm going to do my stoichiometry. Grams divided by the GFM to get it into moles. And then mole to mole ratio of 2 moles to 3 moles of copper, because those are the coefficients in front of those elements from the reaction. And then 1 mole multiplied by the GFM of copper, just so I can go ahead and get that into copper. Okay? So when I do that math, that actually should be rounded out to, that should be a 0. And I think it's because this copper should be, from your periodic table, it should be, yeah, the 63.5 is right. But when I did my math, I rounded in properly. So that's why that should be a 0 there. Okay? Now, that's my theoretical yield, because I calculated it. Now, I was given my actual yield with the 3.74 grams of copper, because that was about a product. So that's my actual, and I divide that by my theoretical, and then I multiply it by 100. Okay? When I do that, I end up with, and I believe that actually is where my other answer was kind of a little messed up, and that should be 50, let me do that math real quick again. 3.74 divided by 6.60, that should give me 56.7% when I actually do my rounding properly. Okay? So that's percent yield, and that's where we wrap up this section as well. So hopefully this helps. Again, this you should work on the worksheet number 4 of your classwork. That is all about limiting reactants. And you don't need to really worry about the excess portion of those questions. And then your homework, part 3, is doing this, and it's set up exactly like your test is going to be, so that you can practice that. Remember, the answers to the homework are posted, not the work, but the answers are there. And then the answers and the work for the classwork are posted as well.